continue with the graph of the polynomial, or we talk about polynomial functions. Okay, we argue that the polynomial, the domain of the polynomial is set of all real numbers. So the real numbers would be integral of negative infinity and positive infinity. So when x goes to negative infinity and x goes to positive infinity, we check the behavior of a values of a polynomial. The values would be getting bigger and bigger, going to the positive infinity, increases without bound, or going to the negative infinity, decreases without bound. We give it the tool and notation to identify it, okay? So we argue that when the values of the x increases without bound, you don't have to consider all the terms of a polynomial. You just consider the term that contains the highest power of the x. So that was the end behavior. Just remind you again, and then we continue. Okay, so the example, just to remind you, we want to define or determine, okay, determine the end behavior of each polynomial function or just function. Okay, the first one is going to be a standard one. So type 1 is going to be something like f of x equal to the negative 4x cubed, okay, plus x squared minus 3x plus 1. This is a polynomial. So what we do is we shrink it first. Okay, so the solution is going to be equal to f of x. We shrink it into its leading term. So that's going to be the leading term. Then we check the infinity here. Okay, in calculus it's going to be limit, but over here we're just estimating. So they estimated from the left to right. So if x goes to negative infinity, okay, then f of x goes to, you have to determine is it a positive infinity or negative infinity. The way we do it, the result is infinity. But which one is it? Positive or negative? You see, negative to the third would be negative, but there is a negative outside, making to the positive infinity. Okay, any question? The other way around, if x goes to positive infinity, then f of x goes to, again, positive to the third would be positive, but there is a negative outside, making to the negative infinity. So that gives us, the nature of the graph at the endpoints. So that would give us an idea. We can check that eventually this is what would happen to the graph of your function. Okay, x negative infinity, this is negative infinity. Okay, and this is positive, so in this case it's going to be up. Say it rises to the left. Okay, and this is a positive infinity negative. This is positive negative, so it's going to be false to the right. So that gives an indication of what would happen for the graph of the function. Okay, any question? So that was case 1, that everything was nicely given to you. But the cases that you're going to have, you have to find your leading term yourself. So you may be given something like, let's say f of x. F of x is equal to the 5x squared, x plus 1 to the 5th, and x minus 1, okay, to the 4th. If this is going to be the case, you have to find the leading term yourself. The leading term is the x with the highest power. So we pick the x with the highest power from each factor and we multiply together, okay? So the solution is going to be, so your f of x is going to be equal to, you see the leading term over here, the highest x is going to be 5x squared. The highest power of the x is x to the fifth, and the highest power would be x to the fourth. And of course, there are some other terms, but you are interested in the x with the highest power. So f of x would be, okay, we can shrink it into the highest form. It's going to be 5x to the 2 and 5 would be 7, 7 and 4 would be 11. Okay, so that would be the leading term. Any question? So we don't want the other terms because we just want to check the infinity. So check the infinity. If x goes to negative infinity, then f of x goes to, you see negative to the 11 would be negative. And there is a positive numbers here, so make it to the negative. And over here, if x goes to positive infinity, then f of x goes to, this is positive to the 11 would be positive, so the result would be positive infinity. Okay, so that's going to be the behavior of your graph when we get to those extremes. So if you want to get an idea, this is it. Okay, so that's going to be a negative infinity, and this is a positive infinity, and the positive up, and the negative down. Okay, so the situation is going to be what? A negative, 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 negative. So over here you go down. Positive, 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 positive. You go up. So this is going to be the nature of graph. Okay, any question? So that was something that we need for the end behavior of a polynomial to be able to graph it. There was another thing that we need. Remember, we argue that we need the intercepts. Intercept is going to be intersection of the graph with the, okay, with the x coordinates. Okay, x coordinate of the y coordinates. The x-intercept is going to be more interesting because for the x-intercept, you let y equal to the 0 and you solve this type of equations. And so we talk about it, sometimes the graph crosses the x-axis or sometimes it touches the x-axis. So we want to know when it's going to be touches or crosses, okay? So we are going to give you these ideas. So what is going to be the nature of the intercepts? We just give you something quick here, then we continue when we get to the next chapter. Okay, so what's going to be the intercepts of the graph, especially x-intercepts? Okay, so let's look at x-intercepts. Okay, x-intercepts of the graph of this function. So we give a couple of definitions that's going to be useful for other purposes. There you are. If, okay, if f is just a function, if f is a function or a polynomial is a function, and then a number, okay, a number. Okay, a number, let's say x is going to be x is a zero or a root, 0 or a root of f of x, okay, if f of x is equal to the 0. Basically, the solution of this equation is going to be called zeros of the function, okay? So the solutions of the equation f of x equal to the 0, okay, these solutions are zeros of the function, okay, of the function f. Okay, so that's the That's the definition of the zeros. So the situation that we're going to have, you know that they are at the same time. This is like you let y equal to the 0 to get the x. So this is in fact the intercepts. So we can say that the following are going to be equivalent. You see the following? The following are going to be equivalent, like each other. Equivalent. The following are going to be equivalent means the first part. The first part means x equal to the r, if you like, is the zeros, or x equal to, let's say, c is going to be, I'm going to use another notation. Your book uses r, which is no good, but I'm going to use that one. X equal to r is a root, is a 0, is a 0 of f. It's the same as, you see, when you want to solve an equation, you need a factor, okay, to be able to solve it. So this means x minus r is a factor. Okay, it's going to be a factor of f. Okay, you let this factor equal to the 0, okay, you let this factor equal to 0, you get x equal to r. That's going to be the one. And the third one is, okay, the third one is x equal to r is going to be an intercepts, okay? X equal to the r is an x-intercepts. X-intercepts. Intercept of f. So these are going to be all equivalent to each other when you get equal to the 0 together. Now, we want to know what's going to be the nature of the, the behavior of the graph at this point. So this is going to be the way we're going to do it. You see, as soon as we get this factor, this is where the graph would intersect, the x-axis. We want to know whether the graph would crosses the x-axis at x equal to r, or touches and bounce back. We look at the power. You see, if it's going to be crosses, the y can be positive or negative. So if the power is an odd number, so you can have a positive or negative. So the graph would crosses the x-axis. But if this power is an even number, if it's going to be even, you see x minus r to the 10. Whatever happened inside is not important. The result is always positive. When it's positive, you don't have a negative or positive to go below the x-axis and the above the x-axis. So in that case, it's going to be touches. Okay, so we put them together and we give you this very nice and easy indicator, if you like, to get it. So there you are. So if, you see, if r is that's it, is a 0, is a 0 of f, and x minus r to the k, if you like, is a factor, is a factor of f. So, it's going to be x minus r, just x minus r. X minus r is squared, x minus r to the third. You say x minus 1 is squared. So this is going to be the case. So there are going to be two possibilities. The first one is that if k is odd, if the power is odd, you can have a positive or negative. If this is going to be the case, then the graph of y equal to the f of x crosses the x-axis at x equal to r. Okay, so when it's odd, crosses. Because you may get a positive number or you get a negative number, okay? When x minus r, you raise it to the k. But if it's going to be even, if k is going to be even, Okay, if it's going to be even, then the graph of y equal to the f of x this time touches, okay, touches the x-axis, touches the x-axis at x equal to the r. Okay, so if it's going to be even touches, because there is not going to be a change in signs, okay? So it's because you know the inside, whatever is inside, you square it to the 4th, to the to the 6. So the graph would have to stay on the top of x-axis or down the bottom of the x-axis in both cases. Okay, that's it. This is all we need to be able to graph a polynomial. Okay, so let's give you an example. Any question? So we are ready to graph a polynomial. Give you an example and we do it all together. So that's it. 1 for your next test. And even on the final, we usually give you 1. It's an easy question. So there you are. Example, would like to sketch the graph. Sketch the graph, okay, of the of a polynomial function, of the polynomial function. Let's say they usually give you 2. But after a little bit factoring you need it, but otherwise the other one is just straightforward. Okay, let's write this one first. Okay, that's it. So we are going to have f of x equal to the negative 3x squared times x plus 1 to the 3rd times x minus 1 to the 7. That's it. This would be given, and then you are going to graph it for us. Remember, on the test, you have to explain it. 2 steps. Identify the end behavior. Okay, that's a step 1. A step 2, identify the behavior of the intercepts. Don't just graph it right away. Give us all this information and then graph it. Okay, so there you are. Solution. Step 1, end behavior. End behavior. Those infinities. You need leading terms. Okay, the term containing the highest power of the x. Let's find the leading terms. So f of x is going to be equal to, get the leading term, I rewrite it so that I can explain it. Okay, this is it, x minus 1 to the 7. Get the x with the highest power for each term. For the first term, it's going to be negative 3x squared. For the second term, x to the 3rd. X to the 3rd. The last one, x to the 7. X to the 7, and of course, some other terms. Okay, so this is going to be a leading term. So you shrink your function into its leading term. Negative 3x to the, add the powers. 2 and 3 would be 5, 5 and 7 would be 12. That's it. So your function would behave like negative 3x to the 7, x to the 12. Any question? Now check the infinities. Here you are. If x goes to negative infinity, then f of x goes to, you see, that's it. The negative to 12 would be positive, but positive negative would be negative, negative infinity. Any question? The other way around. If x goes to positive infinity, then your f of x goes to Positive to 12 would be positive, but there is a negative here, negative infinity. So it's going to be down. You can, can make a note, but you don't need it. Okay, so that's the step one, end behavior. That will tell you where to start and where to end. Okay, that's one. Negative, negative is the first term. This is third quadrant. Positive, negative would be fourth quadrant. Okay, so that's going to be one. Okay, no, we can graph it if you like. So intercepts, that's it, x int. So you let f of x equal to 0 and check. F of x equal to the 0. So you have negative 3x squared times x plus 1 to the third, x minus 1, 7 equal to the 0. Describe each of these intercepts. You see negative 3x squared goes equal to the 0. That give you x equal to the 0. Just tell us what would happen at these points. Graph is going to be touches the x-axis or crosses the x-axis. You see the power is even. Since the power is even, you just write and make a note for yourself that the graph touches the x-axis. Okay, touches the x-axis. Just for your information, k equal to the 2 is even. Even touches, because the result, there is not going to be any change in signs. Okay, any question? Get the other one. X plus 1 all cubed equal to the 0. So that gives x equal to the negative 1. The power is 3. 3 is odd. Since it's odd, the graph crosses the x-axis. Crosses the x-axis because k is 3 and 3 is, is odd. Odd crosses, even touches, that's it. The last one, x minus 1 all to the 7 is equal to the 0. So that gives x equal to the 1. The power is odd again, so it's going to be crosses the x-axis. Any question? Even power touches, odd power crosses. That's it. We are ready to get the graph. Okay, so what is going to be the graph of the function? So that's a negative infinity to positive infinity. And that's a positive infinity, and this is a negative infinity. Identify the intercepts. 0, negative 1, 1. You see this is it. This is a negative 1. This is a 0, and this is a positive 1. You know those crosses and touches. You see this is the 1. So at this point would be crosses. So where are you going to start? You see, where are you going to start? You just look at your end behavior. You see, negative, negative. So this is going to be negative, negative. So we start from here. If you start from here, you go to the negative 1 crosses. You cross, you get to the 0. At the 0, you touches, you bounce back, and then you go to the next point and you crosses. Okay, so this is it. You are coming from here, you turn, you see, and as soon as you get the negative 1, you turn, no sharp corner, remember. You turn, you get to the 0. At the 0, it touches and turn back, bounce back. Okay, another turn going to the 1. In case of the 1, you have to crosses. You crosses. To make sure you get it right, you see at the end, positive, positive, negative. Positive, negative. Okay, it's a down. Positive, negative, and you're done. So that would be the graph of the function. It's very easy to identify. Any question? So the end behavior is important to know what's going to be on. You may come from the top, you see, or you may come from here, 2 cases. So we're going to find out from your end behavior that you got it here. Okay? And for the intercepts, just that's it, crossing, touching. If you get if the power of the factor is even, the graph would touches the x-axis. If it's odd, crosses. Those touch and crosses, just make sure you get it right. And as soon as you pass 1 point, you nicely turn and you go to the next one to get these numbers. Okay, any question? So now we put them together. It's very nice, but those end behaviors are going to be used again. So that's going to be one type. The other one is, you see, very mild factoring, not a very hard one, okay, that you have to do to get this number. You have a couple of them in your, in your book. They are all, they are going to be all easy case to get these numbers. But I just give you one of them to see what would happen for this graphing part. You see, the other one that you have to, so I do the number 76. So this is the next example. That was, okay, this is it. That's the number one. Number two, I give you this one from your book. G of x is equal to, is going to be x to the fourth minus 9x squared. Okay, this is from section 3.2. Okay, 3.2, and this is number 76. Okay, 3.2 number, just to see the type 2 that you are going to have. Okay, you see you have to factor, because you have to find those zeros. Okay, you have to find those zeros. So again, 2 steps. You can go with the first step, which is the end behavior. In this case, it's easier. Okay, so get the end behavior. You need the leading term. Leading term is already given to you. So you have the g of x, which is x to the fourth minus 9x squared. So you simply shrink it by the leading term, x to the fourth. Okay, so we shrink it into this one. Now we check the infinity to see what type of graph are going to have. And so there you are. If x goes to negative infinity, then your g of x goes to negative to the even power that give a positive. Okay, it's going to be positive infinity. And if x goes to positive infinity, okay, then your graph again goes to positive infinity. So it's up, up. You see, in both cases, y is positive, so it's going to be up, up. And you start with the negative positive, you start with the second quadrant. You start with the second quadrant, okay. This is going to be the case, and you end up in the first one because it's up, up. Okay, any question? So that would be useful when you want to get the actual graph. So that would be your end behavior. So we need the x-intercepts. You see x-int. So for the x-int, you have to solve this equation. You know that. It's going to be g of x equal to x to the fourth minus 9x squared equal to the 0. Now you have to factor it yourself. Okay, you factor it, it's going to be something that it's going to be factorable. So we have to pull out the x squared as a factor. So that you x squared times x squared minus 9 equal to the 0. And you have to factor it again because you have to find those, you have to identify each factor because you want to classify whether the graph would crosses or touches the x-axis, okay? So this is going to be x times x squared times x minus 3 times x plus 3 equal to the 0. Okay, this is how far you should go. How far you should go in order to get there, okay, to get your factors. Any question? So the other part, it was nicely given to you, right? It's not bad. So what we're going to do, we let each factor to be equal to 0. So the first factor equal to the 0, that gives x equal to the 0, but the power is even. Since the power is even, your graph would touches the x-axis at this point. Okay? The other factor is x minus 3 equal to the 0. So that gives x equal to 3. You see the power is 1. So it's an odd number, so this means it crosses. And you have x plus 3 equal to the 0. So that gives x equal to the negative 3. X equal to negative 3, and that would be again a crossing one. Any question? So this is the way you do it. Even if you have to factor it, you do your factoring first. Okay, now we are ready to grab it. There you are. This is it. To graph this one, this is a negative infinity, positive infinity, and we have a positive infinity and negative infinity. Okay, so identify your those intercepts. You have the 0, positive 3, negative 3. 1, 2, 3. That is a negative 3. Okay, that's your negative 3. And 1, 2, 3, your positive 3. And this is your 0. Okay, you know what would happen. You have two crossing band touching. Okay, and the point is where are going to start. Okay, but you already decided what are going to do. You go to the end behavior. You see, we have a negative, positive. That's your starting point. So this is a negative, positive. Okay, so you have to start with a negative, positive. You start from here and just keep going. Okay. So you know that you are going to have a crossing at the negative 3. So you come from here, nice cross. Okay, when you cross, go down, then turn, you get to the next one. Okay, turn, get to the next one. At next one, you have to touches. You see, this is it. You touch, you bounce back. You bounce back, you turn, you go to the next one. You see, you go to the next one. At this point, you are going to cross it, so you cross up. See, that's one. And you double check it, you see, you double check it that you must end up with what? Positive, 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 positive. So that give you the final, final answer. Okay, so it's not a big deal, and it's going to be easy operation, and you'll be able to do it nicely. Okay, any question? So this is a situation we're going to have for these type of problems. And again, just do one more from your book and we finish it. Okay, that's it. Usually give you one question, 2 parts. One that, a very mild factoring that you have to do for us to get the graph, and the other one is the one that you just identified there. It's going to be already factored for you. So that is only the last one, number 3. Number 3 is it's h of x. If you want to do 5 problems, just do the odd numbers around the one that I give this one. That would be good for your test. You see, this is number 86 from this section. So it's 3.2, and this is number 86. We can pick the 85, which is very, very similar and easier, in fact. Okay, and this is it. This is going to be your function. This is the one that you have to identify the leading term yourself. So for the solution, you want to get the end behavior. So we have to see the first step we are interested in is going to be end behavior. Okay, there you are. So we have to get that leading term. So it's going to be h of x. We repeat it again. Is 1/3 x cubed times x minus 4 all squared. Now we need the x with the highest power. So this is going to be equal to the highest power of the first one is just as is. Okay. And the second part is going to be x squared plus something else that we are not going to be interested in. Okay. Any question? The term containing the terms containing the highest power of the x. That's the one. So now we know that we can estimate the h of x by what? We estimate it by 1/3 x to the 5th leading terms. Check the infinity. If x goes to negative infinity, you start from the left, and then check the signs. You see negative to the odd power would be negative, and the 1/3 is positive, so that gives you a negative infinity. Okay, this is the one. Now, if x goes to positive infinity, so then what is that? H of x goes to, okay, positive to the 5th would be positive, so that gives you positive infinity. Okay, so that will tell you that you start from the 3rd quadrant, negative, negative, and you end up into the first, positive, positive here. Any question? So that was the end behavior. Describe the x-intercepts. Okay, that's easy. You don't need to factor it. So we did the h of x equal to the 0. Then you are going to have a 1/3 of x cubed times x minus 4 all square equal to the 0. Okay, you let each factor to equal to the 0 and describe it. So we're going to get the 1/3 of x cubed equal to the 0. Okay, so that gives you x equal to the 0. And the power is 3, 3 is odd. So in this case, you are going to crosses the x-axis. Okay, even power you touches, odd power you crosses. So we crosses at 0. Okay, any question? So we continue, we get x minus 4 whole square equal to the 0. So that gives us x equal to 4. The power 2 is even, so in this case you are going to touches the x-axis. Okay, any question? So we get crosses and touches. Now we are ready. We have only 2 intercepts, and we already get the description of the, okay. So this is it. This is going to be XY coordinates. I'm sorry. Okay, that's a negative infinity and the positive infinity, and this is a positive and the negative. Okay, so what we have 2 intercepts. The intercepts are 0. So this is going to be x equal to the 0 and x equal to 4, which is going to be 1, 2, 3, 4. So these are going to be your intercepts, 0 and 4. Okay, you know that at 0 you crosses and at 4 you touches. But the question is where are you going to start and where you are going to end up. We already decided. It's a negative, negative. So it's going to be 3rd quadrant. Positive, positive, you end up in the first. So you have to start from here and you end up here. Okay, so we start from here, we get to the 0. We get to the 0, at the 0 you crosses, okay? At the 0 you crosses, so this is it. We start from here, nice turn, go to the 4. Nice turn, go to the 4, at the 4 it touches. When you touches the 4, you have to bounce back. Okay, and that's it. Automatically you get back to the first quadrant, and this is going to be the graph of your function, and you're done. Any question? So very nice argument, and it's going to be very useful in calculus. And the only extra thing that you are going to do is this is going to be, okay, how far you go up. So that would be the maximum value, if you like, and the minimum value. And this turning, you know, we turn it right away, but in calculus, you just find the interval in which, you know, you do those turning. But over here, the important part is those factors that we determine, really, and then we done, and nothing else. And that would be whatever we need. Okay, any question? So that's a graph of the polynomials. As I told you, nice, many application for future, but for the time being, this is the best we can do. And you see only one question from this one on your next test. So that is section 3.3.2. We are not going to do anything else from this section because we have a big one in the next one. So what is going to be the next two section about? The next two sections that we're going to cover from this chapter, and we finish it, nothing else from this chapter. Okay, these two next sections are going to be very useful for factoring. You see, at the end of the day in algebra, you should be able to solve equation for us, okay? So you're already familiar with if you want to solve an equation, what you do? You try factoring. If you cannot factor it, you know, if it's going to be quadratic, you use quadratic formula. But if we give you an equation with the third degree, the fourth, the fifth, the sixth, the seventh, you don't have any general formula for all of them. So the only thing you can do is you can factor it. And you know that if it's going to be quadratic, you can do it. So if it's going to be cubic, if you can find one of the factor of this cubic one, you factor it into the, you reduce it into the polynomial of a second degree, then we can do it. But what about if your degree is 4, 5, 6? So how are we going to do it? We are going to give you a theorem that enables you to do all of this, really very useful one. In order to do it, the tool is going to be long division from algebra that we don't want to do, okay? So what we are going to do, we are going to introduce a new method. Probably you are familiar with this method. We are going to see the method of, we call it syntactic division. So we do the syntactic division first because this is going to be our tools. And then we are going to give you those theorem, okay? So I'm going to remind you, you may have seen it, this syntactic method when I teach algebra, I talk about it. But anyway, this is officially part of your job. So we are going to talk about it for you, okay? So this is section 3.3.3. It's very easy section, a couple of questions will be given to you, and so useful for future. Okay, so we have to get the division part first, get the tool first. The tool is going to be syntactic division. Then when we are happy about our method, then we go for it and we introduce the techniques that enable us to factor a polynomial. Not just when it's a quadratic, not by when you can find, we try. If you can find a common factor, we can do it. If we can do the grouping method, we can do it. So we are interested in a situation that we have no other choice, okay? So that's a 3.3, okay? 3.3, let's talk about the division of the polynomial, or just syntactic method first, okay? Syntactic division, what is going to be a syntactic division? This is a short form of the division that we're going to use, okay? This is it, syntactic, that's it. Syntactic division for the polynomials. Okay, we remind you the long division and then we do the syntactic one. We need a very mild long division for the next chapter, but we remind you, okay? So long division method first. Long division method. Try this one first because we need it to be able to, okay, to get our problem. So suppose you want to divide this one, okay? Divide. If you want to divide, how about x cubed plus 5x squared minus 3x okay, is going to be minus 3x minus 3. Okay, you want to divide this one by x minus 1. That's it. We just remind you the line division first, and then we tell you that we can shrink the method if you like. Okay, you know that when you want to divide, you must make sure that everything is in standard form. So this means if the polynomial is cubic one, you must have the third, the second, the first, and the constant, okay, in this format. If some of these terms are missing, you know that we can create it. If you need x, we can call 0x, okay, 0x squared. So we're going to we talk about it later. So the line division, you know that for the line division, we want to know how many x minus 1 is going to be inside x cubed plus 5x squared minus 3x minus 3. Now, the line division method is we get the first term and we divide it by the first term here. It's like when it's a division, the first digit, if you like. So we get the x cubed divided by 3 is going to be x squared. We put the x squared on the top, and then we multiply it. So it's a divide, okay, it's going to be divide, multiply. You multiply x squared cross x minus 1. So x squared times x would be, okay, this is it. X squared times x would be x cubed. And continue, that gives you negative x squared. Then we subtract. Okay, to subtract it, we switch the sign. So this is going to be negative and this is going to be positive. These two would cancel out. Okay, so no action over here. And then we combine them together. 5 and 1 would be 6. So we get a 6x squared. Okay, 6x squared. And that's minus 3x minus 3. Okay, that's step 1. Any question? Now we continue. We divide the 6x squared divided by x. So it's going to be 6x squared divided by x. You simplify it, that gives 6x. So we put the 6x on the top, okay? And then we multiply again. And so that's going to be 6x times x. That would give us, okay? So this is it. 6x times x would give us a 6x squared. Okay, and the 6x times the negative would be negative 6x. So we have to switch the signs. Okay, so it's going to be negative positive. We add, these two would cancel out. So that gives you a 3x minus 3. 3x minus 3, we continue. We continue 3x divided by x, that gives you 3x over x, which is going to be equal to 3. So we put the 3 here, so it's a plus 3. Then we multiply again. So 3 times x would be 3x and minus 3. We switch the signs, make it into the negative and positive. These two would cancel out, we get the 0. So it is divisible to get this number. Okay. So I'm going to write the final answer. The final answer, we say we want to divide x cubed plus 5x squared minus 2x minus 3 be divided by x minus 1. So the leftover, the divisors is going to be, x squared plus 6x plus 3, and there is no remainder. The remainder is 0 to get this number. Okay, any question? Now, what's the advantage of this operation? The advantage is when it's divisible, if you cross multiply, you see, if you cross multiply, that gives you what? X cubed plus 5x squared minus 2x minus 3, which is going to be x squared plus 6x plus 3 times x minus 1. If it's going to be divisible, we can factor it. And x minus 1 would be one of our factors. And that's the purpose of this section. to finding these factors. So we divide. If it's divisible by x minus 1, we say x minus 1 is a factor. So we reduce, you see, we reduce it into the quadratic. For the quadratic, we can do whatever we like, okay? Whatever you want, we can do it with this quadratic one. So that's the idea behind this, this long division procedure, if you like. Okay, but we can short this long division procedure that we're going to have. You see, look at this. You see, these x's are not important. The numbers are important, okay? You can drop all the x's. If you drop all the x's, this operation can be shrink. You see, the way we are going to do it is going to be, you see, these two would cancel out. So we didn't do anything with the first action. But the next action is going to be this 5 and the negative 1, which make it to the 6, these numbers. So what we can do is, if you drop all the x's to get the synthetic one, you can take care of these changing the signs by changing the sign of the negative 1 here. Okay, you make it into the positive so that you are not going to change the signs. That would be easier for us to work with. Okay, so drop the x, drop all the x's over here, but start with, okay, start with the positive one. So, and then list those coefficients that we did have. So the coefficients of this is going to be 1, it's 1x cubed, and that's a 5, negative 3, and the negative 3. I'm sorry. You see, that's going to be the first step that we did. So if you want to get those numbers, this is how we're going to get those numbers. You see, we didn't take any action for the first part because this part would disappear all the time. So we bring this coefficient down. Then what we are going to do to get the other numbers, you just multiply these numbers by this one. 1 times 1, okay. 1 times 1 would be 1. That's exactly what would happen over here, you see. In the first step, you have the 5 and the 1. 5 plus 1 is 6. So we do the same thing here. 5 plus 1 would be 6. You see, we get the first number. Okay, and then we continue. 1 times 6 would be 6. So we add them together, that gives you 3. And that's exactly what would happen in the second step. You see, in the second step, this is what you have. We have a negative 3 and 6, which is going to be a positive 3. So that's exactly positive 3 here. And then we continue. 1 times 3 would be 3. And these two would cancel out. So this means they are divisible. Now, how are we going to find the coefficient? You see, these are going to be the coefficient of what? You see, you start with the x cubed. You start with the x cubed, okay? And when you divide, you end up with the x squared. So these are coefficients of the quadratic one. So it's going to be 1x squared, 1x squared, plus 6x plus 3. So that's exactly the quotient that we got. We call it qx. Quotient, okay, quotient qx. So that's exactly what you got over here, you see. X squared plus 6x plus 3. This is x squared plus 6x plus 3. So it's a very much very short form, and we are going to use this one in order to do the division in this section, because we are going to do it over and over and over. Okay, any question? If you have seen it before, you are familiar, but otherwise it's not a big deal. So we list the coefficient of the given polynomials. You have to switch the sign here, okay? And you switch the sign, you bring the 1 down, and you start multiplying, you see? 1 times 1 is 1, you add 5 and 1 is 6. You repeat it again. 1 times 6 is 6, you add, that gives you 3, and then you continue. If you get a 0 at the end, it's divisible. And these are going to be, okay, your result, your quotient. And if you start with the x cubed, so this must be x squared. So that gives x squared plus 6x plus 3. If there is any number, that would be the remainder Otherwise, that's going to be the case. Okay, any question? So let's try one. This is the one we call it syntactic method or syntactic division. Okay, so we are not going to directly ask you to do it for us, but in the course of doing these problems, automatically you have to apply it, because if you want to use the long division, it's going to be takes quite a while. Okay, so let's give you, there are two types that you got to be careful. Example. Okay, so we wanted to divide using, syntactic division, using or by syntactic method. Okay, this is it, syntactic division. Do something quickly. Okay, this is it. We give you 2. Okay, the first one, just to practice. And this is it, 5x cubed plus 7x squared minus 2x plus 1. You want to divide it by x plus 2. That's it. You check to make sure everything is here okay. You must say representative of each powers of x. Okay, these are the one. So use the syntactic method, change these signs into the negative. Okay, the opposite sign. Otherwise, you have to change the sign anytime you multiply. So it's going to be negative 2 into, okay, bring this down, 5, 7, negative 2, 1. Okay, bring the 5 down, start multiplying. Negative 2 times 5 would be a negative 10. Negative 2 times, okay, add them, that give you negative 3. Now negative 2 times negative 3 would be a 6. So that give you 4. Negative 2 times 4 would be negative 8. So that give you negative 7. You see, this is the remainder. It's not divisible. But the quotient function, quotient, qx is equal to, you start with the cube, so it's going to be a square, 5x squared minus 3x plus 4. You have to rewrite it for us. So it's a 5x cubed plus 7x squared minus 2x plus 1 be divided by x plus 2. We get a quotient of 5x squared minus 3x plus 4. But there is a leftover. Okay, the leftover is going to be negative 7. So we can write down as a negative leftover 7 on the top of what? X plus 2. Okay, so it's not going to be good for this section that we are interested in. It's not divisible, but we keep it. Okay, that's type 1. Any question? The type 2 that you should be careful not to miss it. Okay, let's see what is the type 2 one. The type 2 one is this one. Okay, how about 3x to the 4th? Okay, 3x to the 4th. And this is minus x cubed. Okay, it's going to be minus x cubed. And this is going to be plus, okay, plus x. This is going to be plus x and minus 3. And you want to divide it by x minus 1. Okay, that's 1. You see, look at your polynomials. One of the terms is missing. X squared is missing. So you have to rewrite it Don't miss it, otherwise it could be NMS. Okay, you note that x squared is missing, if you like. Missing, just for information in this one. So you have to rewrite it, x to the fourth minus x cubed plus x minus 3. You rewrite it as 3x to the fourth minus x cubed plus 0x squared plus x minus 3. Any question? So since in the synthetic one, you are going to use the coefficient of all the powers, so you must make sure that all the powers are present. If it's not, you have to add as zero term if you like. Okay, now we are ready to change it. That's a negative one, we change it to the positive one. And the coefficient of this new one, 3, -1, 0, 1, and -3. Okay, bring down the first coefficient, the first one. Start multiplying. 1 times 3 would be 3. So you add to get the 2. 1 times 2 would be 2. You add, we get the 2. Okay, that was the 1. So again, 1 times 2 would be 2. We add, we get the 3. 1 times 3 would be 3. It's 0. It's a remainder. Okay, it's factorable or it's divisible. Okay, bring the coefficient, the quotient. Your quotient function is going to be equal to 3x to the, you start with the what? You start with the fourth. So you reduce it to the third. It's going to be 3x cubed plus 2x squared plus 2x plus 3. So what's going to be the final answer? The final answer you write on this form, 3x to the fourth minus x cubed plus x minus 3. We divided by x minus 1, and the leftover is 3x cubed plus 2x squared plus 2x plus 3. As you can see, it's factorable. So you can cross multiply and you get the fact that x minus 1 is a factor. So that's the one that we are going to be interested in. Okay, any question? So that's a warm-up. You see, to get the idea of how we're going to break it, to get those factors out, if there is any factors, there are any possibilities. Now we can put them together as a theorem, talk about it. I'll give you a break if you like. That's 8:24. We come back and we give you a theorem. That theorem will tell us that it's simple. We already done it. That if you divide and you get the 0 as the remainder, this means x minus 1 is a factor. Is a factor means you cross multiply, you factor the polynomials. And that will help you to be able to find, okay, the zeros of the polynomials. You see, those factoring terms that we are going to be interested in. Okay, so we practice on this one. 10 minutes, and then we continue, we try to see if we can finish it. It's very dense section, quite useful. You know, you're probably getting this if you want to go to the calculus business. There are just a very mild situation that you may use it. If you would like to go to the pre-calculus and the trick and just keep going, calculus 1, 2, 3, quite a lot is going to be used. And then there are some more advanced courses like linear algebra, differential equation. In all those courses, you need these methods, okay? There are cases that you have to use it. So quite interesting and useful. Okay, 10 minutes, I'll come back and give you that theorem.
shit.
Okay, any question? So what we did, we just reviewed the syntactic method, okay, for the long division procedure. Now we're going to see what's going to be the application. So as I told you, we are interested in factoring a given polynomial. So this is, originally this polynomial is given. Okay, we want to know if we can factor it. In order to be able to factor it, you need to find out one factor. You see this factor. If we can find this factor, we can divide it. When we divide it, we reduce the power from the 4 to the third, okay, to the third, and then we may be able to take care of this one. So it's important to know the first factor. When it's going to be factorable, if you like, then when you divide, the remainder would be 0. So it's important to know when you know whether it's divisible or not. This procedure that I did, they call it, some people they call it remainder theorem, and some people they call it factor theorem. So the factor theorem will tell you that if this is going to be factorable, if it's going to be divisible, then we can write it down as a factor. Factor means cross multiply. So we just write it down as a theorem, whatever I did. Then we take it from here to see how we're going to, how we're going to do the factoring or what you need. Okay, so it depends how we're going to call it. So I give you both a theorem, okay, that we have. So this theorem, both of them are just one theorem really. Some people like to call this one a remainder theorem. Okay, this is going to be remainder theorem. It's not a theorem really. Remainder theorem means if you divide, you can find, you can find the remainder. So this is it. If you divide, as I did, if f of x, okay, is divided, is going to be divided by a factor. You see, by, we call it x minus c. As I did, divide by x minus 1, x minus 2. Then if there is going to be a remainder, that remainder would be like, then r equal to f of c is the remainder, is the remainder. You see, we talk about it. If it's going to be divisible, you see, if it's going to be divisible, the remainder is 0. The remainder is 0. So in that case, c would be a zeros of the polynomial. So if the remainder is not going to be 0, so this means that f of c is not a factor, if you like. See, c is not going to be 0. So we divide. If it's going to be leftover, that leftover is going to be the remainder. Okay, now, if the remainder is 0, of course, it's going to be a factor. Okay, so it's the same thing, but the conclusion is going to be, so some people, let's say we did only the second theorem. The second theorem, they call it factor theorem. Factor theorem is if they are divisible, if f of x, if you divide f of x by x minus c, and the remainder happen to be 0, so this means x minus c is a factor. Okay, so this is going to be the case. X minus c is a factor, is the factor of f of x if and only if the remainder is 0. Remainder was f of c. So if and only if f of c is 0. That will help us quite a lot. We already talked about it. F of c equal to 0. Remember x-intercepts. I told you that the x-intercept is going to be what? Is going to be equivalent to this fact that we used for the polynomials before. So basically, this means they are related to each other. if you can factor it, of course, if you can, each factor give you one solution. You see, each factor give you one solution. So it's nothing new to get these numbers. Okay, so the way you are going to operate is going to be new. Okay, are you going to operate by substitution to get your, whether this is going to be the solution, or are going to use it the syntactic methods. So I'm going to do an example to see what is going to be the difference between these two type of problems. Okay, so your job is this one. We give you a factor and we wanted to confirm it. Okay, so this is it. We wanted to show that you have quite a lot in your book. Show that, for example, x minus half is a factor. Is a factor of this polynomial, f of x equal to 2x to the fourth, okay, minus x cubed plus the 2x minus 1. You see, you have two choices. You can divide it by syntactic method and show that the remainder is 0. Or you can substitute the 1/2 here. Okay, find f of 1/2. If f of 1/2 happen to be 0, so this means this is a factor. I do both of them for you so that you compare them together. Then I tell you which one are going to be used, in or when. So a solution, method 1. The method 1, divide. Okay, we change this one into the positive half, and the polynomial, you have to change the polynomials. Okay, so the method 1 is going to be a syntactic division, if you like. So in this case, I have to rewrite f of x as 2x to the fourth minus x cubed plus 0x squared plus 2x minus 1. Now I'm going to divide. How many 1/2 are going to be in? I have 2, negative 1, 0, 2, and negative 1. You know that I bring the 2 down. Then I start multiplying. 1/2 times 2 would be 2 over 2, which is 1. Okay, you add them together, that gives 0. So 1/2 times 0 would be 0. So that gives 0. Okay, 1/2 times 0 would be 0. So that gives you 2. 1/2 times 2 would be 1. That gives you 0. You see? The remainder is 0, so it's factorable. So this means x minus 1/2 is a factor. You see? Because you are, you can find the divisors if you like to from this method. So that's one method. Any question? Next method is substitution. Of course, the first one is easier, but method 2. Substitute. Find f of 1/2. If f of 1/2 is 0, so this means x minus 1/2 is a factor. So f of 1/2, I'm going to substitute here to get these numbers, okay? So it's going to be 2x to the fourth, 2 times half to the fourth, minus 1/2 cubed, okay, plus 2 times half, minus 1. You see it's going to be the case. So 1/2 to the fourth would be 16, because 2 to the fourth is 16. minus 1/2 cube would be 1/8, because 2 to the third would be 8. And this is going to be, we simplify it, so I give positive 1 minus 1. 2 and 16 would be simplified, that give 1/8. So as you can see, 1/8 and 1/8, 1 and 1 would be 0. So f of half is equal to the 0. So this means x minus half is a factor. Okay, so two different methods that we are going to have to check that if this is going to be a factor. You can use the syntactic method to get it, okay, or you can substitute. Okay, now, what's going to be the advantage of these methods? You see, this second one is good, but this is just the end. You cannot do anything else if you want to get the complete factorization or find all the solutions. As this method is better because you reduce it to an easier polynomial to continue your factoring, okay? So that they will tell you that just x minus 2 is a factor, x minus 1/2. How about the other factors? Okay, so it's nice to know both of them. In your book, you have some assignments that they ask you to do this method or the other one. But basically, we are going to use the syntactic one because we need the syntactic form. I give you another one to see what I'm talking about. Any question? You see, the syntactic format is going to be this one. You see, look at this one. What is going to be the advantage of a second method? Example. We are going to ask you that show that. You see, we want to show that x minus 2 is a factor of f of x equal to x cubed plus 2x squared minus 5x minus 6. You see, and this is it, and then give us a complete factorization. Find a factorization of f of x. You see, this means you have to do the syntactic one, because you do the syntactic one to confirm it, then you reduce the polynomials into the quadratic one, then you can factor it right away. So that's going to be the case that we are going to use. Okay, so let's do it. And that's it. Syntactic, everything is nice. So we start with we check how many 2's are going to be in. Substitute, get these numbers. 1, 2, -5, -6. Bring the first one down. Try. 2 times 1 is 2. 4. 2 times 4 is 8. That gives you 3. We add them together. 2 times 3 is 6. That's going to be 0. Okay, so this means x minus 2 is a factor, but you have the divisor. Look at this one. You start with the cube, so this is going to be x squared plus 4x plus 3. So this means x minus 2 is a factor. Okay, and we have a factorization. And we have that the f of x is going to be equal to 1 factor x minus 2 times the leftover x squared plus 4x plus 3. You see, that's the advantage of this method. But they ask for the factoring, so we have to continue. X squared plus 4x plus 3, you can factor it. So f of x is equal to x minus 2. You factor this one, it's easy. You need two numbers with the product of 3. Okay, two numbers with the product of 3 and a sum of 4. So the numbers are going to be x plus 3 times x plus 1. You see? We give you a complete factorization. We give you a complete factorization of of the given polynomials. So we need to have to know one of them to be able to do it. For the time being, in the next section, we are going to tell you how we're going to find this one. Then you'll be able to do it, the complete factorization. But for the time being, we have to practice on this one first. Any question? So, you have sometimes this factoring is going to be a little bit more involved. So I'll give you another one. What is going to be the other example is going to be this one. Example. We want to show that. See, show that. We want to show that x plus 6. X plus 6 is a factor. Is a factor of factor of this polynomial f of x is equal to the 2x cubed plus 11x squared, 11x squared minus 7x minus 6, and of course then a complete factorization. Okay, find a factorization, say a complete factorization. You see, complete factorization. Factorization of f of x. Again, for this one, you have to use the syntactic method. So we go with the -6 first to get those numbers. Okay, so this is it. -6 into, how many do we have? We have a 2, 11, -7, and -6. We bring the 2 down. Then we multiply. -6 times 2 would be -12. You add, we get the -1. We continue, -6 times -1, that give a +6, so that give a -1. And the -6 times a -1 would be a +6. That would be 0. So that would confirm that x plus 6 is a factor. So what's going to be the leftover? You see the leftover is going to be 2x squared minus x minus 1. Okay, so this is it. You claim that x plus 6 is a factor, and your function is going to be f of x is equal to, we get x plus 6 times 2x squared minus x minus 1. Inside 1 is a trinomial. It's easy to factor. Okay, so your complete factorization is going to be, so your f of x is going to be equal to, you have the x plus 6 You see, and this is going to be a factoring of a trinomial. We put the 2x and the x here. Okay, you know, you need two numbers with the product of one. You can check it. This is going to be -1 and the positive 1. Okay, we are going to be interested not factoring really. On the test, we are interested in the solution of the equation. We let this one equal to the 0. Even if you cannot factor it, you can use quadratic formula. Of course, this is not going to be difficult to find, to get these numbers. Okay, any question? So if you have one factor, then you'll be able to do it. But the question is going to be how we're going to find that, that one factor. And we have a theorem, in the next section that we're going to do it. But I'd like to give you a couple of questions from your book. There are a couple of them that's not difficult, but it's different. Just make sure. So no long division, you say synthetic method. So in your assignment, there are some of them, they ask for the synthetic and the long division. So go with the synthetic one really, because the long division that we're going to use is going to be very, very mild one in the next section, okay? So you don't need it. But there were a couple of questions over here that I want you to see it, okay? So there was one that I want to explain. Yes, this is going to be the case. They want you to, they give you a couple of example of this format, okay, and they want you to check. This is, let me just explain this problem. Any question? So it is just the main thing is of finding that factor. We give you a nice theorem. I can talk about it tonight, but I may give you an idea, but finish it next time. But you have a couple of problems that we want to check on this section. You see, this is it. Example. You see the numbers are given to you and they wanted to check if this is going to be like the one that I gave you, but this is a little bit different. Okay, so this example is from your book. It's 3.3. 3.3, you get a couple of them with the radical. I want to make sure you feel comfortable. It's a number 66. Okay, this is a number 66. So they want you to find the solution of this equation. It's the same thing. This is the same thing that we're going to do in future. You see, this is it. They want you to show that, especially this number, show that x equal to 2 minus radical 5, okay, is a solution. Of this equation, okay, of the equation is x cubed, because this is the way we are going to use it in future. X cubed minus x squared minus 13x minus 3 equal to the 0. Okay, equal to 0, and then, okay, and then find all real solutions. Of the equation, okay, of the equation, because at the end of the day, we want to use these to get the solution of the equation. We don't want just to do the factoring, algebra, you do the factoring. Okay, so let's see what's going to be the idea of these type of problems. You know that I've already talked about it. So you have two options. Okay, you have two options. You can substitute to show that this is going to be the result, or you can use the syntactic method. Since you want to find this is cubic, so you need to find two more solutions. In order to find the two more solutions, you better use syntactic method to reduce it to the quadratic, then be able to do the quadratic one. Okay, so if it was x equal to 2, x equal to 3, you substitute, but it's not. So they may give you this type of numbers that you are not going to feel comfortable to substitute. Okay, so syntactic method, not the substitution. Okay, any question? Everyone understand the problem? You see, if they want to check that x equal to 2 is the solution of this equation, you substitute. But the number is not the nice one, x equal 2 minus radical. Are you going to substitute here? Good luck, you can't do it. 2 minus radical 5 to the third, or the cube. So that's going to be the advantage of our method that we talk about it. Okay, so we have to use the syntactic method for this one. Everything is right, so check 2 minus radical 5. Don't use your calculator or just decimal estimated, nothing. 2 minus radical 5 into what? Into, this is it, 1, okay, negative 1, minus 13, and the negative 3. This is going to be the 1. So bring the 1 down and carefully multiply it. Okay, that's it. You see, the first one is easy. 2 minus radical 5 times 1 would be 2 minus radical 5. Okay, add them together. You know that when you combine together, you just specify the like terms. Like terms would be negative 1 plus 2. Negative 1 plus 2 would be 1. So it's going to be 1 minus radical 5. That's the first step. Any question? Get the next one. You see, the next one is, this is going to be tricky. 2 minus radical 5 times 1 minus radical 5. You have to take care of this one. Okay, the coefficient was right. Oh, I made a mistake. No, this is going to be too radical. I want to change the sign. No, that's too. Okay, so you have to multiply this one times. You see, this is it. 2 minus radical 5 times 1 minus radical 5. You see, multiply by the radicals, just like a FOIL method. You multiply, you go forward, so that give you 2 minus 2 radical 5. Inside would be negative radical 5, negative positive. Radical 5 times radical 5 would be radical 25, which is 5. Okay, now 2 and 5 would be 7. And this is going to be minus 3 radical 5. Any question? Okay, so you have to carry this one. 2 minus radical 5. 2 minus radical 5. Okay, times 1 minus radical 5 to be FOILed. 2 times 1 would be 2. 2 times radical 5. Then we go inside, negative radical 5 times 1. Negative positive, so that gives us the. Okay, so this is going to be the result here. So this result, we have to put it here. It's going to be 7 minus 3 radical 5. Then we simplify by 13. Okay, 7 and 13 would be negative 6. So that gives negative 6 minus 3 radical 5. Okay, so that gives you this one. Negative 6 minus 3 radical 5. Then we are going to multiply it to see if we get this one. X squared minus 3. And okay, so let's multiply to see if we get that number. I just want to make sure this number is correct. 1 negative 1 is a negative 13 times 3. And that was 2 minus radical 5. Then I add them together. 1 minus radical. Okay, so that we subtracted negative 6 minus 2 radical 5. Then we multiplied again. It's not going to be divisible probably. Okay, if you multiply it, this is it. Oh, that's a good one. Okay, this is it. If you multiply them together, that's a good one. It would be nice. Look at this one. You FOIL it, 2 times negative 2, 6 would be negative 12. You multiply it here, minus 6 radical 5. You go inside, this is going to be plus 6 radical 5. You multiply this negative positive. 3 radical 5 times radical 5 would be 5 times 3 would be 15. These two would cancel out. So that gives you a 3. Okay, so if you multiply these two together, that gives you 3. So that gives you 0 as the remainder. I just want you to see this one. You know, we are not going to give you this on the test, or just show you that this synthetic method should works. Okay, so if you get this, I have another one on my lecture notes, which is much easier. But this is going to be the case. So we just show that this is going to be a factor because the remainder is 0. Okay, so x equal to the 2 minus 2 radical 5 is the solution. Now the remainder that we're going to have is this one. Good luck, you see. This is going to be x squared plus 1 minus radical 5 x, and this is going to be what? Minus 6 minus 3 radical 5 equal to the 0. You see, this is going to be the leftover that you should be able, to solve and get that equation, which is not going to be again, and it can be done. Okay, so this is going to be the case. So the number is not nice, 2 minus radical 5. We cannot use those convenient methods, if you like, that we have before. But synthetic method would help us to get this one. Now, we can solve this equation using, using quadratic formula, of course, to get these numbers. And it's not going to be difficult to solve. Okay, so you have to find the delta. So I put it over here. Any question? So again, algebraically, it's nice. Of course, it takes a little bit more time to talk about it, but it would be done. Okay, you have to use quadratic formula, of course, to take care of this one. So a is equal to 1, b is equal to the 1 minus radical 5, and the c is going to be negative 6 minus 3 radical 5. You have to form the delta to see if there is any solution. Delta is b squared minus 4ac. So it's going to be 1 minus radical 5 all squared minus 4ac. A is 1, and this is going to be your c. It can be, it would be simplified nicely if you just be patient. So your square of the binomial is going to be 1, 2 times first times second, 2 radical 5, and just do it quickly. Radical 5 squared would be 5. And if you multiply this inside, that gives you a positive 24. And the negative would be positive. So that gives you 12 radical 5. Okay. And it must be, okay, it's going to be b squared minus 4ac. So if you put them together, eventually you have to use your calculator for this one. I should give it up. Okay, that's going to be 30. That's a 30. Negative 2 radical 5, that gives you 10 radical 5. You see, this is going to be positive, but you have to use your calculator to get these numbers, because positive means there is a solution. There is a solution, but you have to use your calculator to get these numbers. Okay, negative b plus or minus, okay, radical delta over 2a. Just wanted to say that the one that we have, usually just checking this one as x equals 2 radical 5 would be the solution of the equation, and we don't go that far to get those numbers. But you may use your your calculator to get through it if you like. But make sure you know the first part. The first part, if you see these radicals, don't be afraid of trying. But of course, we are not going to go through the other parts. You may see something like they ask you to check it, to check if this is going to be the solution of your equation, not just solving it through. Okay, so that give you an idea in case you pick one of these radical one in your book. This is it. This is going to be the future, if you like. Okay, so you can avoid it if you like. So I quickly should give you one more, and to show that what is the case, and then we finish it. In case you want to get these type of factors, you see, we just give you one factor because that was cubic, and then you reduce it to the square. If this power is going to be higher, you need more factors. So I just give you another example of, you have a series in your book in case you want to pick one of these fives. Okay, so I give you the one. So this is going to be, to get it at the 5, you have only one with the x to the 4th. So I'm going to do that one for you. This is question number, okay, this is section 3.3, and the number is 69. To want to make sure that if you don't pick this one at the 5 question, but you know it, you see, basically you want to show that. Show that x minus 5 and x plus 4, okay, are factors, or are factors of, okay, factors of this one. F of x equal to x to the 4th minus 4x to the 3rd minus 15x squared plus 58x minus 40. Okay, since this is x to the 4th, they give you two factors. And of course, then they ask you to factor it, okay? And then, okay, then find a factorization, okay? Okay, this is it. Find the complete factorization, okay, factorization of f of x. You see, we did the same thing for the cubic one. For the cubic, you need one factor, but this is x to the 4th, they give you two factors. So you have to do it twice. I just wanted to see how we do it twice quickly. Okay, are you ready? Pick one of them. It doesn't matter. We change the sign, remember. This is x minus 5. You start with the 5. 5 into coefficients 1, -4, -15, 58, and the -40. These are your coefficients. Bring the 1 down. Start multiplying. Get the numbers. 5 times 1, 5. 1. 5 times 1, 5. -10. 5 times -10 would be -50. 8. 5 times 8, 40. 0. Yes, it's a factor. Okay, so x minus 5 is a factor. And what's going to be your factor so far? F of x is equal to x minus 5 times the leftover. You see, look at the leftover. Remember, you start with the x to the 4th. So this is going to be x to the 3rd. Okay, x to the 3rd plus x squared minus 10x plus 8. So we reduce it to an easier polynomial. Any question? Now we continue. We are not going to go back and check the previous one. You see x plus 4. We check that x plus 4 in this leftover here. You see here. Because you want to factor it, okay? We check to see if the factor are this new one, okay? For the second factor, x minus. So we change it to the -4 and then we continue. -4. The same coefficients, 1, 1, -10, okay, and the 8. We bring the 1 down, and -4 times 1 would be -4. That gives me -3. -4 times -3 would be +12. Okay, that gives us a +2. -4 times 2 gives us a -8, 0. Yes, it's a factor. Okay, so x plus 4 is a factor. Plus 4 is a factor. And what are we going to have now? F of x is equal to, we already got x minus 5 as a factor. Now we have a second factor, x plus 4 left over. Left over, look at this one. Remember, you start with the cube, that's going to be a square. So it's going to be x squared minus 3x plus 2. Now we can factor this one easily. So f of x is equal to x minus 5 times x plus 4 times, you know that this is going to be x minus 2 times x minus 1. That gives it the complete factorization of the given value. This is the type of problems that we are interested in. That's it. You see? That's going to be the one that we're going to be interested in. Those radical ones that I did was just for information, of course. You're not going to have those type of. So syntactic method and this one over here. Any question? There is only one question that we are going to answer next time. The question is, how are we going to find that first factor? You see? If you know yourself that what's going to be that factor, then you should be able to do the rest yourself. There is a theorem that I'm going to talk about that next time. You see, we find it from here. This 40, look at 40. We check the divisors of the 40. 40 is divisible by what? Divisible by 1, 2, 4, 5, 10, 20, 40. These numbers are going to be possible solutions, possible known numbers. 5 is one of them, and the -4 is the other one. So we need to find the first one, and we are going to do it next time. It's a great theorem. We call it, it was proved by René Descartes, the famous French mathematician. Okay, but we have to do lots of trying, because those are the possibilities. This doesn't mean they are the solutions. Okay, and we do it and we finish it. Okay, but so that's a very nice concept, as I told you. It's very easy. It's not difficult. Those radical one is not going to be coming because we can use calculator. But these are the one that be able to confirm that there is a factor and keep going to be able to give us the factorizations. And the question is going to be how I'm going to start. We are going to tell you next time. So you find a starting point and keep going to get that one to the end, and then you're done. 2 questions on this one on the next next test. Okay, and we are done. Any question? So we talk about that one in the next section, the 3.4. I just give you that theorem, then we finish this chapter. Okay, that's it. Any question? So I will finish your quiz and we may go over that one too tomorrow and put all those grades together. Then if it's going to be anything missing, then email me, not now. Okay, that's it. Have a good night. Take care and see you on Wednesday. Any question? Have a good one.